Good day, Algebra. We are starting PO22 today. Likely going to be a 2-day objective. A, because the POs, I want to make sure we cover it well. And B, because we only have about 17 minutes left anyway on the short class. So we're only going to get through half of it. This objective, it focuses on what's called slope-intercept form, which we've talked about. We're familiar with that. We've worked with it before, okay? And something called standard form, right? So, and the page we'll get to today is converting from slope-intercept into standard form. And then next Tuesday, because Thursday is a retake day, and Monday you get new seats. Although,
yes,
it's a new trimester Monday. Although it'll go more quickly because Fate now knows you. It knows exactly who you should and should not sit by, so it'll go lickety split. So Monday probably we'll get into the second part of this. But first things first, let's review quickly slope-intercept form. What is slope-intercept form? Aiden? Y equals mx plus b. Okay, we worked with that in CO21. You were introduced to it last year. You graphed it. You've seen it before. Y equals mx plus b. And remember, we talked about what that is. It is the parent form, or the most common form for a linear function. It's easy to graph, basically, because it gives you the y-intercept. That's where you begin, right? And it gives you the slope for how you move. Another way to write a linear equation is called standard form. Does anybody know what standard form looks like?
It has like A's. It has an A in it.
There is an A in it.
And a B.
And there is a B in it. And there's a C in it.
And it's
A plus B.
It's like
Integers.
A1 plus
A plus B
B1
equals.
Kind of, yeah. Okay, we're actually pretty close here. I'm pretty impressed. AX plus BY equals C.
I did not learn.
Okay.
I don't.
AX plus BY equals C. Now, last year when you did this, it was CO35, I want to say, and it was just a CO. This year it's a PO, because the ability to manipulate an equation to get it how you want it to look, to go from slope-intercept form, standard form, back again, is a skill that you'll use very frequently as we go forward. So, a couple things to note here. I heard someone say something about integers. Who was that? You said the word integers. What you remember what you said? What? Yes, good. Anything else? Something to do with integers. Yeah. Anybody else want to expand on that? Anyone remember from last year?
It's a positive or negative number?
It is.
A,
Okay.
B, and C all have to be in it.
Yes. A, B, and C. Oh, yeah, right. A, B, and C all must be integers. Whereas slope-intercept form, we invite the fraction for slope because it tells us the rise over the run. We want that to be a fraction. In standard form, A, B, and C all have to be positive or negative non-decimal, non-fraction numbers. Okay. Notice the use of the capital B compared to the lowercase b. The fact that one's capitalized and one's lowercase means that they're different. Okay. This B you have in slope-intercept form will not be the same B that you have in standard form. Okay. So a couple quirks there. But the steps to convert from slope-intercept to standard form. Step one, again, starting in slope-intercept form, and at least move the page down a little bit so you can kind of see the purpose for this. What does slope-intercept form have that a standard form equation can't? We kind of just went over this. Fraction, right? Slope-intercept form has a fraction. Standard form can't have a fraction. So step one is to get rid of the fraction. Okay, and how do you mathematically undo a fraction? Not a percentage. That's not a bad guess because it can be converted.
Oh, like
Not a decimal because decimal's not an integer either.
I was going to say divide.
multiply it out.
Like if you divide it out, it's going to end up being a decimal.
No,
Multiply by what?
100.
You're very close. I think Hugo's got it.
But it did not multiply by the denominator.
Okay, step one, to undo a fraction is you need to multiply that fraction by the denominator. Like let's just take this 3 halves here, and you don't have to write this down if you don't want to. But if we multiply 3 halves by its denominator by 2 over 1, what happens to those 2's? They cancel out, right? Or if we multiply this out, 3 times 2 is 6, 2 times 1 is 2. What's 6 divided by 2? 3. The fraction's gone. Okay, the 2's end up canceling out and you're left with 3 over 1. So to undo any fraction, to turn any fraction into an integer, you multiply by the denominator of that fraction. But since we're dealing with an equation, if we multiply one thing by something, we also have to multiply everything else by that something too. Okay? Otherwise, the value of the equation is going to change. So step 1, finally get to write this out. Step 1 is multiply each term by the denominator, and I'm going to put this in red because we'll deal with it shortly, or LCD of the fraction. Multiply each term by the denominator or the LCD of the fraction. What does LCD stand for?
Like common.
Very close. You got 2 of the 3. C is for common, D is for denominator, least common denominator. Because you will occasionally have 2 fractions, okay? And to undo both fractions at once, you want to multiply by the least common denominator of the fractions. Okay? But the key here, this sometimes gets missed, multiply each term. If you don't multiply each term, then you're going to change the value of the equation, which is a problem. Okay? Then, step 2 is using opposite operations. Using opposite operations, move the x term to the other side. Because we want x and y to be on the same side, right? Standard form ax plus by, x and y are together. In the slope-intercept form, they're on opposite sides. So once we undo the fraction, we then move that x term over using opposite operations to be with the y. And that's it. Easy peasy, right?
Yep.
Sure. Questions? Light bulbs flickering from last year, perhaps? No. That's all right. Well, that's okay. That's all right. Okay. Let's go over the first one. Anyone still jotting down the notes?
Yeah.
Okay.
Done.
Thanks. Thanks for the update, Facebook.
Can I wear your hair split tomorrow?
I don't think so. I better go see Heather with all natural.
What's Heather's? No, like after your.
No, I don't even know, to be honest with you.
Who's Heather?
She's my stylist. I'm getting my hair cut.
I'm surprised she's not
That's what I said
Where did
yesterday.
your haircut? What place did your haircut?
They are not a sponsor of my channel, so I'm not going to give the name.
Nobody watches your channel.
Wow. And that's why you don't have any merch.
Only
That
your
right
secret.
there.
Only your
Okay,
secret.
number 1.
Subscribing.
Y equals 4x. Emmett, stop now. Y equals 4x plus 7. Do we have any fractions to worry about here? No. So we don't even have to do step 1. We can go straight to step 2, which is using opposite operations, move the x term over to be with the y. What does that mean that we do here? In order to move the 4x's over, using opposite operations, what step is that going to require? Hugo?
Subtract 4x.
Subtracting 4x from both sides. Normally, when we deal with a coefficient and a variable, we're using multiplication or division. The reason why we don't here is we don't want to split the 4 from the x. We don't care what one x is. We can keep those 4 x's together. We just want them on the other side of the equation. So if we have 4 x's on the right, we subtract 4 x's. Now we have no x's on the right side. Okay? I put negative 4x because that's the opposite of a positive 4x. Okay? If I have 4 x's, I want to move them, I have to take them away. That's the subtraction. And then on the left side, y minus 4x, can I actually combine those?
I don't know.
Let me. No, I can't. Okay? Because one's an x and one's a y. So I keep them separate. Negative 4x, which is written first because standard form has the x term first. Negative 4x, if the y is positive, so plus y. And then what's left on the right side is my c term, 7.
Wow.
That's it.
Where's the B?
Okay? What is the b here? 1, right? You don't have to write it, but it is technically a 1. Okay? Technically a 1. What's confusing about it? So, do you understand why I subtracted 4x from both sides? Okay? Because according to standard form, which is ax plus by equals c, where do I want my x's? On the left side of the equation, right? With the y's. Okay? In Slope-Intercept form, my x's are on the opposite side of the y's. I want them on the same side, which means I have to take these 4x's and move them over to be with the y. And whenever you move something from one side of an equation to the other, think solving an equation, getting x by itself, we use opposite operations. Okay? I don't want 4 x's on the right, I want 0 x's there. So I have to take these 4 x's, subtract them from the right side, so remove them. Follow me? Okay? And if I do something to one side of an equation, I have to do it to the other side too. Otherwise our scale is going to be 1. So if I don't have any x's over here currently, and I take away 4, what's 0 minus 4? Negative 4. Okay? And that's how we get negative 4x plus 1y equals 7. The next one, we already kind of talked about this, how to undo that fraction. Since this does have a fraction, we have to launch into step 1. And we're going to multiply everything by what? 2, the denominator of the fraction. Multiply by 2, multiply by 2. Even the y term on the left side, everything gets multiplied by 2. Because if you double everything, the value of the equation is not going to change. If you double only some things, then it will change. Think like a recipe for mac and cheese. Right? You want to make 2 boxes rather than 1 box. If you double the number of noodles, you have to double the amount of butter, the amount of milk, the amount of powdered cheese, right? Otherwise, it's going to taste different. If you only double the noodles but use just 1 pouch of cheese and 1 cup of milk, whatever it is, it's not going to taste the same. Okay, so you double something, you double everything. The fraction is why we do this. Those 2's end up canceling out. And instead of 3/2 x, we now have 3x. Because when you multiply 3/2 by 2, the 2's cancel out. Or if you multiply it out, 3 times 2 is 6, 2 times 1 is 2, and 6 divided by 2 equals 3. So the purpose of multiplying this fraction by 2 is to cancel out the fraction, make it not a fraction anymore. And we're left with just 3. Yeah?
Would we make it into an equation like we did for the first one, or would it just be 3x?
Well, yes, we're not finished yet here. No. Because now we also have to multiply the y by 2. And what's y times 2? 2y. Okay? And then our constant, -5 times 2 is -10. So our equation is now 2y equals 3x minus 10. Yes, 2y. If you multiply the fraction by 2, you have to multiply everything by 2. So 2y. Yes. Now step 2 is to move that x over. Exactly. Yeah. You double it in the first place because that's what my denominator is. If this was a 7, I'd multiply by 7. If it was a 10, I'd multiply by 10. If it was 55, I'd multiply by 55, right? Whatever the denominator is, that's what you're going to multiply by, okay? So anyway, yeah, Evelyn, now we have to move our x's over. How are we going to do that? By subtracting 3x. Why subtraction? Because it's positive to begin with. The opposite operation of a positive 3x is to subtract, or a negative 3x, right? Same situation as we had before. We can't actually combine our x's and the y terms because the variables aren't the same. So kind of like in the first one, we're just going to kind of bring that 3x down. The 2y is positive, so it's going to be plus 2y. And then that equals what's left over, that constant, -10. And so this would be the same equation, just in a different form. The same equation, just in a different form. If we were to graph this, it would be exactly the same. It's just written differently. Gus, hand up. Okay. How are we doing so far here? Yeah, it's okay. Ask a question. I mean, it's better to ask your questions now than have it be a PO and be stumped and then. Well, we haven't done that one yet, so. Yeah. Okay. We're not going to start the next one just in the interest of time. So what I would like you to do for, good golly, Monday, these three here. Okay, just that second row. So don't worry about that third one. We'll cover it then. Okay, but those three for Monday. What's that? Nope. We're not gonna worry about that one. Yes. We're not gonna worry about that one. We'll cover it together Monday, but we're out of time, and I want you to practice with stuff we've already kind of talked about. So another 3-question homework assignment, and you have Wednesday, Thursday, Friday, Saturday, Sunday, and if you do one Monday morning, you can do like half a question a day and still get it done in time for math. We can do this, people. I believe in you. Okay? All right, that's how you math.